Hello students, today we are going to start a new chapter of grade 10 Science and Technology, Unit 12 Universe. So this chapter is not so new to you, right? You have heard this term in your previous grades as well. So, but the thing that you learned in grade 9 of the chapter Universe and that you are going to study now is similar, but it is quite different. It might be similar, but it is different. So, we will start this chapter with some basic revisions from grade 9. So, in grade 9 also you had the chapter of same name. You had a chapter named Universe. So, we will not do the revision in very detail, but we will look at it very briefly. Okay, so we are starting this chapter with a recap from grade 9, and we will start with the unit of measurement, which is quite important in the field of astronomy. So, whenever we are measuring something, we must always measure using the suitable unit of measurement. Okay. For example, if I want to measure the distance between, let's say, these two hands, then I might be using centimeter as the unit of measurement. But if I want to measure the distance from Kathmandu Valley to Ilam, then maybe I will use kilometer or miles or whatever is suitable, but I will not use centimeter. That won't be suitable to measure long distances. So according to distances, we must use suitable unit of measurement as well. So since we know one basic thing about universe, it is quite vast. So we will start with the measurement of distance in universe. So the first one is light year, as you can see. So some of the students might get confused. The term light year, since this term has the word year, many of them assume that light year is the measurement of time, but it is not. Light year is not the measurement of the time, rather it is the measurement of distance. So the basic definition of light year is, it is the distance that light travels in 1 year in a vacuum. In grade 9, you have derived the relationship of light year into kilometers, and 1 light year is equal to 9.46 into 10 to the power 12 kilometer. So, another unit of measurement of distance that we use for very much larger distances is astronomical unit. In short form, it is used as AU. So, 1 AU is the distance. It is the average distance between the Earth and the Sun. That is also used as the unit of measurement of distance. And 1 AU is nearly equal to 150 million kilometers. So these two are some basic units of measurement of distance which we studied in grade 9 as well. So another topic that we studied in grade 9 was about nebula, about black hole, and you also studied about the life cycle of stars. We will not go in much depth on those topics, but we will look at it briefly. Okay, so here in this slide, in the diagram, you can see a nebula. And this is not some ordinary nebula, it is not some imaginary nebula and all. This nebula is known as Orion Nebula. I think you have heard the term Orion, right? Mostly during winter seasons. If you look up at the night sky, you will be able to see Orion constellation. So, between the Orion constellation, there, if you look at the sky with a very good telescope, you will be able to see Orion Nebula. This is the illustration, so you won't be seeing exactly this image, but you will be able to see the dust particles or the clouds of dust and gas particles between the Orion constellation. So what exactly is nebula? Nebula, it is simply a giant cloud of gas and dust in space. And another popular name of nebula, we also call it the birthplace of stars or nursery of stars. Why? Because this is the place, or let's say this is the structure where new stars begin to form. The Orion Nebula that I just mentioned, new stars are forming in this nebula currently. So it is in the making process of new stars. Okay. So another term is black hole. And this image that you are seeing in the screen, this is the very first image of black hole. But what exactly is black hole? So, firstly, these objects aren't really holes. According to its name, it is not exactly a hole. They are huge concentrations of matter which are packed into very tiny spaces. So, since huge matter are packed into tiny spaces, they are very dense material, or let's say they are very dense celestial body. How dense is it? It is so dense that gravity just beneath its surface is very strong that nothing, not even light, can escape. I think you have heard about this a lot. Like black hole, it has very intense gravity and light cannot pass through it. So this was one of the reasons why the image of black hole was not being able to be taken before in the early ages, let's say. Okay, but scientists, as I mentioned, the image shown in this slide is the first image of black hole, which was taken in 2017, but this image was released at 2019 after all the stacking processes. So this is the first actual image of black hole. Previously, we used some illustrations and our own imagination, but again, the thing is, how did they take this image? Because we just mentioned that not even light can escape. So scientists, they used 8 different telescopes known as Event Horizon Telescope. They used 8 different telescopes in various which were placed in various locations, and they stacked all the images that they caught from this telescope, and then they were able to give this output image as shown in this slide. So here is another illustration of black hole, and it shows how a black hole pulls materials from a neighboring star, as you can see in this diagram right here. So we have talked about nebula, we have talked about black hole. We will talk about the life cycle of stars later. Now let's look at some celestial bodies which we have heard. We will learn about them briefly. What is this? I think your answer is star. This is a star, and this is again not an ordinary star. The name of this star is Sirius, which is the brightest star that we can see. So what exactly are stars? Stars are simply massive balls of gas, mostly hydrogen and helium, that generate light and energy through nuclear fusion. In the formation of the star, or let's say in the life cycle of the star, it all started at nebula, right? So gradually when it went to the stage of protostar, the gravity also started to pull other dust and gas particles towards it. And at very high pressure and temperature, nuclear fusion reaction started. In nuclear fusion reactions, hydrogen nuclei, they fuse together to form helium nuclei. So during this process, huge amount of energy is being released, which we get it as light or heat energy. Okay. Okay, now let's look at this. This is the, you might be thinking this is a image of solar system. It is, but we will be discussing here about the planets, which is another celestial body, which is another common celestial body that we have heard. So according to IAU, International Astronomical Union, So basically this organization is related to astronomy. They have some certain criteria to define certain celestial objects as well. So with the general meeting that was held on 2006, they decided to define planets with some certain basic criteria. A planet is a celestial body. First criteria is it should be in orbit around the sun. Its second criteria is it must have sufficient mass for nearly round shape. And last but a very important criteria, it must have cleared the neighborhood around its orbit. So these were the criteria that was fixed by the General Assembly on 2006 for the definition of planet. So if some celestial bodies matches this criteria, we call that celestial body as planet, else it is not a planet. Okay, so now when we are talking about not a planet, let me show you another image. Can you figure out which celestial body is this? Although it's written dwarf planet, what exactly is it? With this heart-shaped spot at its body, we are able to recognize that this is the image. This is the image of Pluto. Okay, so Pluto was once planet, and then again it was removed from the list of planets. Now on the same meeting 2006, where they decided the criteria for any celestial body to be a planet, in the same meeting it was decided that Pluto is no longer a planet. So they were termed, Pluto was termed as dwarf planet. Why? Because it fulfilled the first and second criteria. Its mass, it had sufficient mass, which was almost of circular shape, which almost had a circular shape, and it was in the orbit around the sun. But the last and the most important criteria, Pluto was unable to clear the surrounding or neighborhood in its orbit, due to which it was announced that Pluto is no longer a planet, but it is a dwarf planet. Okay, so another very popular term among us is asteroid. So what are asteroids? Asteroids are simple small rocky objects which orbit around the sun. So they are mainly found in between Mars and Jupiter. The space between the Mars and Jupiter are known as asteroid belts. There are lots of asteroids in between, but it does not mean that asteroids are not elsewhere. They are in other parts, they are scattered in other parts as well, but huge amount of asteroids, they are mainly found in between Jupiter and Mars. So nowadays lots of investigations are going on with this asteroid as well. They have collected some samples and brought back to Earth, and they are studying on it to study about the origin of life as well. Okay, so another similar term, many students might get confused between this term and asteroid. So comets and asteroids, they are very different celestial bodies. Earlier I told that asteroids are small rocky objects. So the composition of asteroids are mainly rocks and metals. Whereas in case of comets, most of the comets are icy objects. So comets are icy objects, and their main characteristics, when they pass by the sun or nearby the sun, it seems like they have generated a tail. So what exactly is the tail part? So since it is an icy object, so since they are icy objects, when they get close to the sun, due to the heat, the heat causes them to release gas and dust, which might seem like their tail, as shown in this diagram. And this comet which you are seeing in the screen, this comet is Halley's comet. So this is one of the most studied comets Why? Because this comet, the study of this comet made the scientists realize that comets might occur twice, or let's say more than once in the site of the Earth. Meaning, lastly, this Halley's comet was seen during 1986, and this will again be visible from Earth at 2061. So, it will occur again after its cycle in the Sun, during its cycling period around the Sun. Okay, so this is galaxy. So earlier we studied about asteroid, we studied planets, comets, right? So stars as well. So all of this here here in this diagram you are seeing a galaxy. It has all those celestial bodies. So galaxy, they consist of stars, planets, vast clouds of gas and dust, all bound together by gravity. So we have very interesting concepts about galaxies as well. So most large galaxies, they have supermassive black holes at their centers, some with billions of times the sun's mass. So in large galaxies, at the center there are black holes. That does not mean that the black holes are present just at the center of the galaxies, but it means that at the center of the galaxy there is a supermassive black hole. Okay, so when we are studying about galaxy, we will look at some basic types of galaxies as well. Okay, so according to its shape, we can say that this is a spiral galaxy. It has some basic criteria as well. It has the following criteria. You can see the spiral arms right here. These are known as spiral arms, and it also has a central balls right here. It is disc shaped and halo also can be seen around this, and in the spiral arms right here, young stars are also found. These are some basic criteria of spiral galaxy. Next one is known as elliptical galaxy. You can see just by looking at the image, it matches its name, right? Because it has an oval or ellipsoid shape. So it does not have a disc-like structure, it does not have arms like spiral galaxy, but instead it has a ellipse or oval shape. And here I earlier told that in the spiral arms their young stars are found. But here in elliptical galaxy, uniform distributions of stars can be found, and their structure is also generally smooth and featureless. Okay. So, before going further to our content, let's try to do some questions. Choose the correct alternatives. So, our first question is, which of the following is true about black holes? Option A, black holes have infinite size but no mass. Black holes prevent even light from escaping. C, black holes are objects that are not affected by gravity. And option D, black holes are visible to the naked eye. So I think you are already guessing the answer, and I hope that is the correct one. So the correct answer for this is option B, because we just studied that black hole is so dense that its gravity is so strong that even light cannot escape from it. Okay, so let's look at the second question. What would happen to Earth if the Sun were suddenly replaced by a black hole of the same mass? Okay, so before proceeding to the options, you look at the options, I will explain this. So, instead of Sun, if we bring a black hole, what will happen? And the very important key point here is given, same mass. So, black hole also has mass. So, if the mass is same, the effect of the gravity will be same. It does not mean that just by being a black hole its gravity is intense. The gravity of black hole is intense because it has very dense matter, like they are being squeezed in a very tiny space. But if it is of same mass, then the effect of gravity will also be same. So with that information, let's look at our options. Option A, Earth would be pulled back into the black hole immediately. It is wrong. Option B, Earth would drift off into space while escaping its gravity. See, if the mass is same, it cannot escape its gravity. So it is also incorrect. And option C and D, you can see the Earth would continue orbiting the black hole with no sunlight, and option D is the Earth would be destroyed by the black hole's immense radiation. So from these two options, we can easily choose the correct one. The Earth would continue orbiting the black hole with no sunlight because the mass is same. The only difference is there is no light of its own like the sun. Okay, so now let's continue with the types of the galaxy. We studied two types, spiral galaxy and the next one was elliptical galaxy. So we will look at one more type of galaxy. As you can see, just by looking at its scattering nature, you can see this is the irregular galaxy. So irregular galaxy, it is simply a galaxy that does not have a regular or symmetrical shape like spiral or elliptical galaxy, because spiral, we could see spiral arms, central balls. In elliptical galaxy we saw its shape, its oval shape and ellipsoid shape, but in irregular galaxy there is no such symmetrical shape of its, and they seem to appear chaotic and lack the distinct features like I mentioned earlier. As you can see, why is it chaotic? Because everything is scattered here and there. It's not in certain orders or it does not have any symmetry. That is why it seems to be chaotic. Okay, so there were that was like three types of galaxy we just studied. Now let me show you this image. I think you have seen this image somewhere in the internet or in your social media. Sometimes people who go to an area like of certain height and where there are less light pollution, they take such pictures. What do you think is this band? Yes, so this is Milky Way galaxy. This is our home. So our galaxy is Milky Way galaxy, and you might be thinking like, how are we on Milky Way galaxy and clicking the picture of Milky Way galaxy? It is simply like we are on Earth and we are clicking some other part of the Earth using our phone camera, right? So we can click the image of Milky Way galaxy by staying in this galaxy. It is thus that we are clicking at the other part of the same galaxy. So we are about some facts. Let's see. We are about 27,000 light years away from the galaxy's center. So what is at the center of Milky Way galaxy? Okay, so earlier I mentioned that at the center of the galaxy a supermassive black hole is located, or it is there, right? So in our galaxy also there is a supermassive black hole and its name is Sagittarius A. Okay, so with this I think we have covered some brief introduction about galaxy and even about our home galaxy as well. And along with this, our neighborhood galaxy is Andromeda galaxy. Okay, so now I'd like you to look at this image. Look at it for a while and then raise some questions, like what questions arise in your mind. So here, some noticeable thing. Here you can see Kathmandu metropolitan city, and on the bottom right corner you can see a time is given and date is given. And if you look at the date very carefully, it's written 2025 12:30, meaning it's December 30th, which is which is in the future. Let's say it's not present or past. And here you can see There is Jupiter, Sirius, Canopus star, Rigel, Uranus, Moon, and Saturn. Some of the basic celestial, some of the common celestial bodies have also been mapped out. So this is a sky chart. Okay, so this is a sky chart. It gives the sky chart of this date. From where? From Kathmandu metropolitan city. So on this date, you will be able to see this. Okay. So some questions that you might be thinking of is, how can we predict the night sky chart? So okay, so for us it is easy. Okay, we can simply use some free softwares and we can predict this night sky chart. But what about the scientists? How do they predict this chart? And another question that you might be thinking is, why do planets appear in different positions on different days? Because some days in news we were hearing about the alignment of the planets, and right now when I showed you the chart, we did not see such alignment. We were seeing some other thing, some other chart, right? So why does it happen? And another one is, why does the moon stay in orbit around the earth instead of flying off into space? So whatever questions arise whatever questions that have arisen might be similar to this one, and the answer is in this diagram. The answer is in this video. You can see whenever you see some people sitting under a tree and something falling on his head, the instant name that comes in our mind is Newton, right? So Newton and apple and under tree, the another term is gravity or gravitational force. So all the answers to our questions that was just arising, all the answer is gravitational force. So what is gravitational force? You have studied this in force and motion as well, and you have been studying about gravitational force in earlier grades as well. So let's go into this definition. It is the force of attraction between any two objects with mass, and this force pulls objects towards each other, and the strength of this force depends on the masses of the object and the distances between them. So gravitational force, every body in this universe, every two bodies, let's say every pair of bodies in this universe, they have a force of attraction between them. But the force of attraction, it all depends on its mass and the distance. So this force of attraction is directly proportional to the product of the two masses, and it is inversely proportional to the square of the distance between two masses. So we also call it as Newton's gravitational law or universal law of gravitation. So with that, we have a mathematical expression, F equals to gmm by d square, where capital G denotes the universal gravitational constant, whose value is 6.67 into 10 to the power minus 11. Okay, so gravitational force, we will just study about it briefly, as I mentioned, because you have studied this in another chapter as well. So you must know gravitational force is the force of attraction between whom? Between two masses. And what does it depend on? It depends on the masses and the distance. How does it depend on it? So it is directly proportional to the product of two masses and inversely proportional to the square of the distance between two masses. So with that, we have this formula. So now let us look at some consequences of gravitational force. Okay, so we know that it is the force of attraction. What are its outcomes or what are its effects? Let's look at it. Number one, formation of new stars and planets, orbit of planets and satellites, tides on Earth, and free fall. Let's look at these points. Okay, formation of new star. Well, the chart shows you the life cycle of star. So what happens here is in the stellar nebula, when the dust particle and gas particles with their gravity start to attract other dust particle and gas particles, it comes at a stage, or it forms a structure known as protostar. When it further starts to attract other dust particles, other objects from the neighborhood surrounding, the mass becomes very dense and the temperature also starts to increase at a very high temperature and pressure. Now the hydrogen nuclei starts to fuse together and they start to form helium nuclei. So when this nuclear fusion reaction happens in this mass, now they release very high energy, and after certain time the inward and outward force becomes equal. That is when a star is said to have formed and it is in a stable state. It is also known as main sequence star at this stage. So there are two probabilities, like two predictions about what might happen according to the life cycle of star. So if the star is average, it might end up being a white dwarf. Whereas if it is very massive, there might be supernova explosion causing it to form neutron star or black hole. So black hole is formed if the so formed star is very absolutely massive. Else it will form neutron star. So the formation of a star, what we just talked about, it is all related to gravitational force. Due to the gravitational force, the dust particles and the gas particles, they were able to come together. So this is one of the consequences of gravitational force. Another one is orbits of planets and satellites. So here you can see a man-made satellite, and moon is also one of the satellites. So we can see that moon does not drift away in space. It is always revolving around our planet. It is always with us. So moon also has its own gravitational force, due to which it tries to go in a straight path. But due to the mass of Earth, we know Earth is comparatively much more massive than the moon. So due to the gravitational force of Earth, it pulls the moon towards its side. So it does not fall on the earth because it has its own gravitational force. It does not drift away in the space because the earth has its gravitational pull. So due to which the moon has its own orbit, and similarly other artificial satellites are also revolving around our earth doing certain studies. They have their own planet due to the gravitational pull or gravitational force of earth. Another interesting consequence is the tides on earth, that we see tides on ocean. It is due to the gravitational pull of moon and sun to the ocean on the earth. This is the reason you can see the balls of tides at certain areas. Due to the locations and its angle, we can see the balls of tides also changes accordingly. So the cause of tides on earth, on the ocean, is also due to the gravitational pull of moon and the sun. So another interesting consequence of gravitational force is free fall. As you can see, normally I think you have seen about skydiving. When people jump, they do not go directly to the ground, right? Why? Due to the influence of air. Due to the influence of air, they are unable to go directly to the downward. But what does free fall mean? Free fall means if a body is falling towards the surface, or let's say downwards, just under the influence of gravity. We neglect all other obstacles like air resistance or air influence. If some object is falling only under the influence of gravity, we call it as free fall. And this free fall is also one of the consequences of gravitational pull. Okay, so in our today's class, we did some recap from grade 9, and we also studied about our home galaxy, our neighborhood galaxy, some bright stars, right? So along with that, our major focus was on the gravitational force and its consequences, some of the few consequences that we have mentioned. So with this, let's try to solve some questions here. Choose the correct alternatives. Okay, so first one is, which of the following best describes gravitational force? Option A, a force that only affects objects on Earth. Option B, a force of attraction between any two masses. Option C, a force that only affects celestial bodies. And option D, a force that only affects objects in space. Okay, so when we talked about gravitational force, we had a mathematical formula, mathematical expression, F equals to gmm by d square, where g denoted the universal gravitational constant. Okay, so we are using this term universal. Okay, and when we talked about force of attraction, it was not just about the objects on the earth. It meant that every pair or every masses in this universe, every two masses in this universe, they have some sort of force of attraction between them, right? So with that, we can easily figure out the correct answer. So our correct answer is option B, a force of attraction between any two masses. So it is not just on earth, or not just about celestial bodies, or not just about the space. So it is from any place between two masses. Okay, so our last question is, if you were to visit the moon, how would your weight vary from what it is on Earth? Okay, so before diving into the options, what do you understand by weight? It is the effect of gravity to your mass, right? So means it depends on the gravity again. So option A, you would weigh the same as on Earth due to equal gravity. Option B, you would weigh much more because the moon's gravity is stronger. Option C, you would weigh much less due to the moon's weaker gravity. And option D, your weight would be the same but you would feel lighter. Okay. So we know moon is comparatively very small celestial body in comparison to Earth. So its gravity is almost 6 times lesser than the Earth, which means obviously since mass is constant, it is conserved, so there is no change in mass. So obviously our weight would also become less. So the correct answer for this is option C, you would weigh much less due to the moon's weaker gravity. Okay, so in today's class we mainly focused about on gravity. In next class we'll study much more about universe, its origin, and some of the basic theories about the origin of universe. So study well and we shall meet in our next class. Thank you.